Okay, so here's our third problem for this session. Hilaan na may bagsakan. Two blocks are connected by a string that passes over a pulley with radius r and moment of inertia I. The block of mass m1 slides on a frictionless horizontal surface. The block of mass m2 is suspended from the string. Find the acceleration a of the blocks and the tensions t1 and t2. The string does not slip on the pulley. So, pansin mo may non-slip condition tayo given by this one. Oh, ano yun? Given by this one, and we see here that therefore satisfy dapat yung non-slip conditions natin v equals r omega or a equals r alpha. So I'll just show you the solution to this problem. Okay, sige. Okay, so here's how we solve the problem. We will assume first na yung mass 2 ay yung babagsak. So therefore, mass 2 will have a downward acceleration of a vector here, whereas mass 1 will have an acceleration given by this. And then the moment of inertia, I mean the pulley will have an angular acceleration. Siyempre, pag bumagsak yan ng ganyan, merong kakaroon ng angular acceleration kasi iikot yung I, so yung pulley. So therefore, meron kang dapat angular acceleration dyan. So first, what we need to do first is to draw an extended free body diagram. Of the pulley and the free body diagram of the masses. Okay, so first we draw the free body diagram of mass M1, and from here, ano yung mga forces na nag-act sa M1? Ano yung mga forces na nag-act sa M1? Pansinin niyo, kung napansin niyo, of course, it will have a normal force and the weight. Siyempre, may weight ang isang object. But the only significant force that we will be considering is the tension due to the rope, so or due to the string. So meron ako ditong tension. Tapos, meron din akong normal force dito. And then meron akong weight downward. Just like what we did in our Newton's laws when we solve free body diagrams, diba? So, yan, hindi yan bago sa atin. So this is normal. This is the tension T1. This is the normal force N1. And this is the weight given by M1, G. Okay? Clear ba tayo dito? Clear ba? May questions ba? Wala? Okay, sige. Now, what about mass M2? For the second mass M2, what are the forces acting on M2? Again, syempre, may weight yung M2, which is downward. May weight yung M2, which is downward. So this is some downward weight here. And then, it also has an upward tension given by this. So yan. So, what I will do is I'll put a really large dot there, really large dot there. Hinuli ko yan kasi para lang kasi may issue sa drawing. Pero sige. Then I have here tension T2 and then weight M2 G vector. Now, I also specify the direction of the acceleration. So the mass 1 will accelerate in this direction, whereas mass 2 will accelerate in the downward direction. They will have the same acceleration because because the string is stout. Therefore, walang kung ano yung acceleration ng isa, yun rin yung maging acceleration ng isa. So in that case, A will be the same for both M1 and M2. Okay, and then we also have the extended free body diagram of the pulley. So the pulley has an extended free body diagram kasi importante agad sa atin dito kung nasaan nag-act yung mga forces na meron tayo. Okay, so let me first draw a circle. And then the forces that are acting on the pulley are the following. Of course, meron yung normal force exerted by the pivot on the pulley or by the support on the pulley. Also, meron din yung weight, of course, yung pulley. But for now, we will not consider it in our analysis because we know that the pulley will not fall down. So, static naman lahat ng mga yan. So, wala tayong maging issue sa ating analysis for the pulley. Okay. Now, for the meantime, ang importante sa ating mga forces ay yung tensions exerted by the string on the rope, or by the string on the pulley, I mean. So in that case, ang mangyayari ay, so ano yung mga forces? So, one force will be tangential and to the left. It's going to the left. One force will be tangential and it's downward. So ang itsura niya ay meron akong force sa papunta rito. And then meron akong force sa papunta dito. So ganyan. Okay, so in that case, this is T2 vector, and this is T1 vector. Okay. Now I will also specify the direction of the angular acceleration to be in this direction, and then I'll draw the center of this row of this pulley, and I'll designate that the radius of that pulley is r. It's given in the problem that the radius of the pulley is r. Okay. Now that we have the extended free body diagram, let us set up the equation of motion. With the assumption that the direction of the acceleration of A or alpha is positive. Okay? Yeah. Now, so for the first mass, again, we're not interested in the vertical direction of the masses kasi wala naman siyang relation dun sa horizontal motion ng mass M1. Hence, we will not include it in our analysis and say that the summation of forces acting on X for the first object, for mass 1, is simply M1A, which is just equal to what? Since the only force acting in the horizontal direction is T1, then I'll just write it as T1. So this is, let's say this is equation 1. Okay, for the second mass, we have summation of forces acting on the y direction for the second mass. Now, again, as I said, the direction of the acceleration is the one that's positive. Therefore, the one that's positive in M2 is downward. And hence, I will write this as M2A, which is just equal to M2G minus T2. So this is equation 2. Okay, again, this is nothing new. We have already encountered this in our Newton's laws when we solve free body diagrams and solve the equations of motion, set up these equations of motion here. Walang bago dyan. And then for the pulley, use Newton's second law for rotation. So in that case, I have summation of torques. It's just equal to, it will give rise to an angular acceleration. Now, again, in our convention, the angular acceleration is the one that's positive. But in the ordinary convention, if the direction of alpha is into the paper, it is negative because the rotation is clockwise. Pero sa atin, ang clockwise ang magiging positive. Kasi nga, gusto natin yung angular acceleration ay positive. So into the paper is the one that's positive in our convention kasi our alpha is the direction of the pulley is clockwise. So alpha here is positive. It's clockwise. It's into the paper. Alpha into the paper is positive. Now, what are the torques exerted on the pulley? So first, we have the torque exerted by T1, so we have R multiplied by R cross T1 out of the paper. And the angle between them is 90 degrees. So I have an R, but it's out of the paper. Therefore, this should, in our convention, it will be the negative one. So we have this should be minus R T1. And on the other hand, R T2 into the paper that's parallel to the direction of alpha. Therefore, it should be the positive one. So therefore, I have a minus RT1 plus R T2, which can also be written as R quantity T2 minus T1. This is equation 3. Okay, so let me rewrite the three equations. Again, just for simplicity, you have M1A equals T1, M1A yan. I have an M2A equals M2G minus T2. And then I have an I alpha equals R times T2 minus T1. Again, I'll reset the number in this equation 1, equation 2, and equation 3 again. So now the question is, observe here that how many unknowns do we have? We have A, T1, T2, and alpha as our unknowns. But we only have 3 equations. Tatlo lang equations natin, 4 yung hinahanap natin. Hindi kulang pa tayo ng isang equation for us to get a unique solution. So what's the 4th equation? Now recall that the rope does not slip on the pulley. And hence, our alpha, the angular acceleration of the pulley is related to the linear acceleration of the rope and hence the acceleration of the blocks. Therefore, I can write this as A equals R times alpha. This is equation 4. Okay, so there you have 4 equations and 4 unknowns. We can now solve this problem uniquely. We can now determine what we need. So what I will do first is to, just like what I did last in the previous problem, I will first solve for the acceleration. Again, the acceleration is the one to be solved because it is common to all of the equations that we have. Okay, except equation 3, but we can do something about equation 3. Okay, now the first thing that I will do is I add equation 1 and equation 2. And from that, we will see that I have an M1A, I have an A quantity M1 plus M2 equals an M2G minus T2 plus T1. So this is equation 5. Okay, so from equation 5, we also have this relation equation 4. We can eliminate alpha in equation 3 by rewriting equation 3 in terms of alpha. So substituting equation 4 to equation 3 and then isolating T2 minus T1, we have an I. So I have an I quantity A over R equals R quantity T2 minus T1. Okay, and then what I will do is divide both sides by R to see that this is T2 minus T1 equals to I over R squared multiplied by A. So this is equation 6. This is equation 7. And then after that, what I will do is I'll multiply equation 7 by -1 on both sides, and I'll see that I have T1 minus T2 equals negative I over R squared times A. So what I did is just multiply both sides of equation 7 by -1. Okay, and what we have here is observe that I can write equation 5. From equation 5, I can write this as, let me move this first. Move ko to. I can write this as M2G minus the expression T2 minus T1. Or actually, this should be this should be M2G minus the quantity T1 minus T2. Hindi. Sorry. The point here is actually I don't need to simplify this. I just need to write this as M2G plus T1 minus T2 para hindi tayo malito. Okay, but we already have an expression for T1 minus T2. Ito yun, no? T1 minus T2 to, pero ito rin T1 minus T2. Diba? So I can substitute equation 8 to equation 5 so that what we have here is that A quantity M1 plus M2 equals G, ano yan? This is equal to M2G. Angat ko ng konti para kita natin. Hindi pala kita. I have an M2G minus I over R squared times A. So this is equation 9. And then I'll transfer this equation here to the other side and see that, okay, I have an A. And then factoring out A, we have A multiplied by M1 plus M2 plus I over R squared equals M2G. So this is equation 10. And thus, solving for A, hence, solving for A, we have A is just equal to M2G multiplied by the expression M1 plus M2 plus I over R squared. That is our expression for the acceleration of the system. So, ayan. Ayan na. Yan na yung magiging acceleration natin. Okay? Sige. Questions? May tanong ba? May tanong? Wala? Wala? Okay. Sige. Now, to determine the tension, T1, substitute equation 11 to equation 1. Recall that equation 1 is this one. So this is our equation 1. Oy, buti na lang, madali lang. Kasi I just need to multiply M1 by A and I got the answer. So T1 equals M1A, which is simply M1 multiplied by M2G all over M1 plus M2 plus I over R squared. And ayun, yun ang sagot. So this is just our tension for the first tension, or the tension that's exerted on the first mass. So this is equation 12. Okay? So determine T2, medyo mas mahaba to. Substitute equation 11 to equation 2 so that we have T2 equals what? Remember, this is the second equation. Ito yon. Ito, M2A equals M2G minus T2. So yan yung gagamitin natin. So M2A equals M2G and we can solve for T2 in terms of A and G and say that T2 equals M2 quantity G minus A. Kasi nilipat ko to dito, nilipat ko to, ito. And then, yeah, so this is equation 13. And then substituting, so we have T2 equals M2G multiplied by 1 minus, A here is again M2G all over M1 plus M2 plus I over R squared. And this is just equal to M2G multiplied by M1 plus M2 plus I over R squared minus M2, wala na dapat dito, minus M2 all over M1 plus M2 plus I over R squared. So, but the M2 here will cancel, and hence, therefore the tension for the second mass, the tension exerted by the second mass is simply M1, M2G all over M1 plus M2 plus I over R squared. That is our expression for the tension of the second mass. Questions for this problem? May tanong ba sa problem na to? Wala? Walang tanong? Okay, so if there are no questions, okay, sige.